Hello, welcome to ADI Books Deeper Dive. We're on physics today, and I am Krista Sampson, and I will be moderating this webinar. And I am here with our presenter and author of the physics book, Victor Sampson, and he's going to walk you through kind of how the platform works and then jump into the physics book. So I will hand it to him.
So let's go ahead and get started with this. So today we're talking about physics. We have two versions of the physics books. We have one that's aligned with the NGSS. That has 9 different investigations in there. I include the table of contents for that here on the screen so you can see what's going on in there. And we also have one that's written for Texas educators that's aligned with the TEKS for the physics course. As you'll notice in that they've got different investigations because the two sets of standards are focusing on different things or emphasizing different kinds of concepts. So we wanted to make sure that we have things written especially for those two sets of standards. So today I thought I would introduce one from the NGSS book and kind of do a deep dive into that to kind of illustrate what our physics investigations look like. And for this one, it's called Orientation of a Compass Needle. So it has to do with electricity and magnetism, which are always challenging concepts to teach for students to grasp. Because they involved unseen entities. So let's talk a little bit about this and what this looks like. So this investigation, always like all of our investigations, starts off with a phenomenon. So this is the handout for the orientation of a compass needle investigation. And what we then do is play a video for students so they can see something in action. We ask them to write down things they notice on their own. Then they can share that out with the rest of their team or the class. Then the teacher kind of takes those and waits for the right opportunity for student to mention something that's related to the guiding question. In this case, why does changing the orientation of a coil of wire affect the orientation of a compass needle? When that comes up, they introduce this task as what we're going to be trying to figure out. Then we ask students individually to create models of what they think is happening or why as an answer to that question. Then they share those models with their team. And as they're sharing their models with their team, they're going to start to realize they have pretty incomplete explanations and they're not really sure why things are happening. And this uncertainty leads to a bunch of new questions that their team can put down of what would they really like to figure out that would move their thinking along or would like to know about to move their thinking along in this investigation so they can answer the guiding question. So that's what the task stage of that looks like. When you purchase one of these books, they all come with a book code. And what you can do as a teacher is you can go into our Learning Hub, which is at adilearninghub.com, and you can create a free teacher account that just is your name and an email address is all you need. It'll ask you for your book code. You enter that book code, and then that imports all of the investigations that are found in that book into your library in the Learning Hub. Once you're there, you can download all the handouts for those investigations, so you don't have to photocopy them out of a book, and you can do color copies if you want to, or just at least cleaner copies. And it also gives you a presentation mode. And what the presentation mode does is designed to work like a slide deck. So instead of you having to make your own slide deck to kind of move kids and guide them as they're moving through an investigation, it's already there for you. So this picture here on the screen is an example of the first activity of this investigation where we're introducing the phenomenon. So by logging in, pushing presentation mode, you can just put this up on the screen and then students can follow along. The coolest part about it, I think, is all the videos and images are embedded in there. So you can just click and go. So let me show you the phenomenon video for this investigation here. So kids would, when you show that video, you can then go on to the next kind of page on that deck, and then have students write down things they notice. And one of the things they'll bring up is how changing the orientation of that coil affects the compass, which is exactly what they're going to end up figuring out in this investigation. So the next stage we move into is what we call the idea stage. So since students have all of these questions that they have from their the uncertainty that was raised from their initial models, we now start introducing some science ideas. So in this one, we talk first a little bit about magnetic and electric fields, what's their properties, what they look like, how you represent those. When we do that, we make sure that kids read through these texts and then pick out ideas that are going to be useful for them for figuring out that helps answers their questions that they've already came up with. So each handout includes one of these bubbles for them to write those ideas down. One of the things I usually do when I'm teaching, especially the first time we do one of these, is I'll usually just read the text aloud, and then have kids in their groups talk through what they thought was useful or important. They write that down as a team, then they share out some of those ideas. We write those ideas down on the board, and then and go through each group, sharing all the things they think is important. And then I give everybody a chance to write down the things that I put up on the board as extra things in case they missed anything. Works really slick. The next idea we introduce is the idea of magnetic flux. And same process where we can read and pull out useful ideas for what we're trying to figure out. And then we end with the idea of circuits and how do you measure those and how do you put them together and these different pieces there. So they don't get an answer to the guiding question at this, but they are introduced to the pieces of the puzzles that they can use to figure out the answer to the guiding question. Now, what we do in the Learning Hub is, once again, we have all of this text in there that's the same that's on the handouts that students will have. So you can shine this or you show this up on a screen and talk through it. There's actually a button that allows you to go full screen, and you can change the size of the text as well, all in there to make it easier to read. In some of our investigations, we also include videos rather than images to help explain the concepts. A lot of the time when you look at a handout, things like magnetic fields or things like that are really hard to represent through just drawings or describing through words. So what we have done is actually added extra little quick videos in there that you can put in there. They're all embedded in the Learning Hub. Let me show you what one of them looks like. So what's nice when you're reading over these ideas and talking about fields, instead of just having a static drawing about that, you can add, we've added videos that make it really easy to help illustrate those ideas. In addition to those, we also have images as well in there. So what's nice about these is you can click on these and bring them full screen. So they're easier for everybody to see. I know when every time I'm teaching and I copy a handout, the copies never turn out quite as well as you want them to do. It's really hard for kids to see the pictures. So we added them all in here. So it's really easy that you can blow them up, talk about anything you want to, point anything out for kids. It makes it really simple to help them kind of think about these important ideas that they're going to use during the investigation. So after they've got these science ideas, we move on to what we call the plan stage. And the first thing you do in a plan stage is you show kids what they're going to have available to use for designing and carrying out their investigation to fill in the missing pieces of answering the guiding question. In this one, what I would usually do is recommend having the stuff that's available to them out on a table, and you can hold it up and kind of talk about how it works. You could also give them some ideas about how you can set up the equipment, not necessarily what to do in terms of trials or what procedure to follow, but ways that you can start measuring things, because those are really hard to come up with for novices, right? So in this case, you can tell them what materials you have, and then you can show them how you can use compasses to look at air and look at a magnetic field and around a wire, how to set that up. We include those pictures in the Learning Hub, or you can just demo it with the supplies that you have there. Once they have some ideas about what they can do and how they can measure things, we then allow them to take some time to work in a group to plan out their investigation. We use these graphic organizers to get them started. Basically, what's the question you're trying to answer, what observations or measurements that you're going to use or collect, how you're going to go about getting those. We always like to have them draw a picture because it helps kind of clarify what they're going to do and set up. That works well whether you're working with juniors and seniors or kids in 2nd and 3rd grade. Pictures really help. And then probably the biggest and most important part is once you have these observations or measurements with this setup, what are you going to do with them? How are you going to analyze that? So kids can fill these out in groups, and then there's a spot at the bottom for you as a teacher to come around and check it off and say, okay, good to go. It's not really to make sure that they have the most perfect investigation, but just so A, you can help them if they get stuck, or B, make sure that their investigation is not going to be a waste of time and it's productive. So I usually give little nudges here about, hey, you might need to add this, or hey, have you thought about adding a control group, or X, Y, or Z, depending on the nature of the investigation. Once they have that plan, we move into the do stage. They grab their equipment and they go ahead and set it up. In this case, this is what they're doing during this investigation. So they're creating a circuit, running a current through a wire, and then using compasses to examine the magnetic field lines that are around that. So you can do a different distances away from the wire. Then you can switch the direction of the current and see what happens there. So they're collecting this kind of information at this point. We include on handouts a place for them to write down their ideas, and then also a place to take their data or observations and transform that into evidence. So we often call that making sense of your data. And if you do that, then you can have an answer to the guiding question at the end of this. So I'm really thinking about data and evidence being different, and that you have to really transform data into evidence to really be able to make sense of anything that's going on. So at the end of this stage, they should have an answer to the guiding question. So since multiple groups work on this problem, they're going to have probably different kinds of evidence that they've generated, and they're going to have different answers. We want them to share what they think they figured out. To do that, we have them do them on whiteboards. They're usually about 2 foot by 3 foot, so about the size of a poster. It makes it really easy for students to interact with each other and show each other's thinking. We ask that they put 4 things on the boards. What's the question? Keep everybody on the same page. Their claim, what they figured out, their evidence for that, and then their justification of the evidence, which is why did you decide to include that evidence? Why did you collect the data that you did? Why did you just try to determine it? Why didn't you transform it in the way you did into evidence? And that usually comes into the ideas that were introduced earlier in the idea stage. So they'll talk about, in this case, magnetic fields and flux and currents and those kinds of things there to start talking about what that means. They then share out their arguments with each other. Lots of ways they can do that. They can do a gallery walk, modified gallery walk, get a thing of sticky notes, go around and give each other feedback. However it's done, it's not important as long as kids are interacting with each other's ideas. To help them make sure that they're taking up these ideas and the good ones, we have this little spot on the handout for some ways so they can write down notes that about things that they can change. So if they're at somebody else's whiteboard and they see a great justification, they can say, oh, that's a really good idea. We should add that to ours. They can add it in this box and then come back to their group and share. Or if they're sharing their argument at their board and somebody else gives them some advice, they can write that down. And then at the end of this session, all the kids get together in their group and revise their board and make it better, with the idea that you're going to finalize your best product of what you figured out. Help students with that in Learning Hub. We also add extra graphics that have extra scaffolds, so those are always there if you need them. Not necessary if it's not needed, don't need to show them, but they're there in the Learning Hub for you. Then after everybody's got a finalized argument, what you want to do is bring everybody together into a whole class format and have a reflective discussion about the core ideas that they were using during the investigation, as well as the practices they engaged in. Often to do that, we will recommend showing a picture for them to explain. In this case, once again, we actually use a video in that, and then we encourage them, once we show this video, to use what they know about magnetic and electric fields and magnetic flux to explain what's happening. So let me show you the video here real quick. It's pretty quick. So when they see that once again in their small groups, can you explain why the needle moves that way? What's going on? What's happening based on all these ideas that we know? They can share out, talk between groups, reach consensus. You can correct any misunderstandings at that point. So it's a really nice conversation that you have. Once you've talked about the core ideas, you can then move on to talk about practices. And really, when it comes to science, we're really thinking about the best way to get valid and reliable evidence. So usually discussions at the high school level is thinking about what you did during your investigation to increase the confidence and the quality of your evidence that you use. So we ask them what you do to increase your confidence. What are some things that you might have done differently to get better evidence now that you've done this investigation once? And then moving forward, what kinds of things can we do or always keep track of or keep in mind the next time you design to carry out one of these investigations? To help kids kind of internalize that conversation, we have a spot on their handouts where they can write down notes to their future self. So what you can do is encourage them to say, okay, over all this content we talked about, what do you want to remember for the future, whether that's for a test or just for your own good? And then you could talk about what kind of things do we need to keep track of when we're doing investigations and planning those out that we always need to remember and keep in mind when we're doing that. Write those down because we can come back and refer to this later. And it helps you get better at what you're doing. It's a really nice kind of feature about being able to learn from your mistakes. Finally, students have been working in small groups or hello class for all through this model. So now we ask them to work on themselves or work on their own. And we ask them to write a brief report about what they figured out. And the goal behind the report is twofold. One, it helps them learn how to communicate through writing in more effective and nuanced ways over time by practicing. And then the second part of it, because you're writing about the content and you're writing to explain and persuade, it makes you think about the content deeper. So by having to explain it, you have to have a good understanding of it yourself, and this idea of going through and saying, oh, this is how I would explain this, or I'm not sure about that. So you can start off with a set of sentence starters like this, let everyone write a rough draft. You have an introduction, what were you trying to figure out? What was your method that you were trying, what did you do to figure that out and why? And then what's your argument, basically what you figured out and what's your evidence for that. It then goes through a peer review. The way the peer review works is I recommend you put students in groups of 3 to do this. So you collect, so if you have a class of 30 students, you're going to have 10 groups of 3. You collect everybody's report, so you have 30 rough drafts to get reviewed. You give one rough draft to each different group, and that rough draft should be written from somebody outside their group. Okay, so you give one copy of that and this peer review guide. You ask one student to be the recorder for that group. You give them 15 minutes to read over that report as a team and then fill out this peer review guide as a team. It's framed around questions. So the recorder basically asks the questions and then they decide the answer to that as no, somewhat, or yes. If they say somewhat or no, they have to then figure out what kind of feedback they would give the author to help them make the report better. At the end of 15 minutes, you collect this one. You give each group another report written by somebody else outside their group, another peer review guide. And you ask for a new recorder. They read the report all together. The new recorder fills all of it out. At the end of 15 minutes, there's the second one done. Then you collect that from them, give them one more report written by somebody else, new recorder, new review, 15 minutes, you're done. So what ends up happening is in 45 minutes, you've gotten every peer review group has reviewed 3 people's papers. Okay. Everybody in the group has had a chance to be the recorder. And then everybody in the class has had their report reviewed by a group of 3. Okay. So at the end of this, everybody's got feedback from what they've done. So you can give those back to the students, and then they can rewrite the reports and make it better. And then that can come to you as the teacher. And what I usually have them do is give me their first draft, their second draft, excuse me, and their peer review guide that was filled out by somebody else. And then I go through and read their final draft, and then I can use the exact same peer review guide now as a scoring rubric and attach points to it. And then I have a nice summative assessment of everything they've learned during this investigation. So you might be thinking to yourself, whoa, that's a lot. How do I remember all of those things? So in the books, we really tried our best to design the lesson plans to make them easy to follow without being overwhelming. So, for example, for this investigation orientation of a compass needle, we start out with an overview, what's the guiding question, what they figure out. Then we include stages that they can move through and how you can divide that up over multiple days. All your standards, not only just the science ones, but language development and Common Core, English language arts, because there's doing so much reading, writing, speaking, and listening during these investigations. We include the things to know before we start in the lesson section. That's the kind of the core ideas and cross-cutting concepts that you're going to talk through during the reflective discussion. Also things you can keep in mind to help nudge kids along toward this understanding. We have detailed lists of materials, pictures about how to set up, safety precautions to think about, waste disposal if that's a thing in that investigation, but that's all outlined for you. And then finally, for each stage, you have multiple activities within there. So we divided up the lesson plan by each of those activities within a stage. So this image shows you the first 2 activities of the task stage, and they tell you how long it should take, what you're grouping, what you should do, what you should give out, what to show. And those are all kind of just suggestions based on how I teach it, I guess. But you can modify those, but it's a good starting point. You also have a box called the teaching tips. That's usually around management. And then there's boxes that we label as attending to equity that really focuses on how to support all learners and advice for doing those kinds of things and extra things you can do to support and make them feel more included, especially like students who don't talk a ton or are learning a new language or maybe are struggling with reading. All things to make it as fair and as beneficial to them as possible. So we've got a few minutes left here. We got some time for questions. Anyone want to ask one?
Looks like we have one from Alaya. If you, hopefully I pronounced your name correctly. If you want to go ahead, it should unmute you. Go ahead.
How are you guys? All right, I love this. Just if you could go back when you started with the report and you were saying why it was helpful, your audio went out for just a moment. Yep. And you were saying it was just, I'm just writing all this down so I can take it to my admin when I ask them about this. But I love how this is set up because we need so much more scaffolding within the lessons because that prior knowledge is just, I think what I used to be, I didn't realize how much I was dependent on their prior knowledge, maybe 5 years ago, right? Yep. So a lot of that has diminished. So I love how this is already built in. But I did want to just get the detail of in terms of how you present it. You were saying one of the first advantages of having this report.
So one of the 2 things that it does, you can think of it as learning to write and writing to learn, right? So
right.
when you write about something and you're trying to explain what that thing is and persuade someone that that's accurate, it really forces you to think deeply about the content, right? So you can't do that without thinking. So it really makes you kind of solidify what you know in a way that you can explain to somebody else. And the other part of it is just learning to write, right? So writing is such a huge part of everything we do, not only in science, but in life. So the more opportunities that they get to figure out how to write in a scientific context, how to support their ideas, where they're not just writing about your favorite element, but you're actually figuring out, you're actually writing about something that you've figured out and you want to share that. Those are your two biggest benefits of doing this kind of thing.
Yes. Now I've seen the books also for because we have more physical science students than physics. But do you still have this same setup in the book for physical science, that integrated physical science and chem? Okay.
Yep.
All right. This is outstanding. Okay.
Fantastic. All right, we're gonna have to stop there because we gotta get to another webinar that starts like right now. But just to wrap it up, we're doing IPC, which is integrated physics and chemistry, right after this in exactly 30 seconds. If you want to catch any of these things, you can go to our YouTube channel. If you scroll down there, you're going to see playlists, and that's our virtual book tour. Click on that. You can watch any of these again.